Ladies and gentlemen, welcome to video number 23 in a series of video lectures which are companions to the book The Fivefold Sun, composed of 15 volumes over 6,000 pages, which was filed at the Bibliothèque Nationale de France in Paris in late 2017. Today we are on December the 7th in the year 2018, about a year later. Today we address the issue of a sequence of period doubling oscillations in the solar activity variations, which would represent a set of poloidal oscillations as is suggested in this book. In the previous video, we introduced another period doubling sequence of solar oscillations, the base period of which was the Hale cycle, which is twice the Schwabe cycle, which will seem to you a rather straightforward notion compared to the more complex sequence that will be introduced today. Part of this sequence of poloidal, so-called poloidal oscillations is in fact remains speculative in nature. I would have liked not to have to introduce such a level of complexity in the set of detected solar oscillations that was found during the Fivefold Sun project. But there are indications, evidence and observations that such a sequence might actually exist. Therefore, we introduce it today with the goal to encourage researchers to check this hypothesis. These are the 6 main spectral peaks detected in observations in this project that can be assigned to a sequence in which every length would double compared to a base period of 30.1 years plus or minus 1 year. As you remember from an earlier video, the base period is a so-called 3-cycle, which is actually detected unambiguously in poloidal as opposed to toroidal solar activity variations, whereas the other lengths that are shown in this table do not rest on especially poloidal evidence, except perhaps this one. The 3-cycle is detected in the geomagnetic AA index inter alia, which represents variations in the sun's open field as opposed to the closed field in which emerge sunspots. You see that there are many reports, 16 reports and 19 reports, net of the reports of troughs in the same period bin for this base period, and also even more for its approximate double period, but also for these very long periods of respectively 487 years and 969 years. We will go now through each of these 6 spectral peaks. The base of the sequence was already introduced in an earlier video. It is idealized as this sum of 3 cycles, only 2 of which have the same length, and they are identified in poloidal indicators of solar activity variations. It is important first to remark that in the sunspot record there is a trough at 34 or 35-year period, which indicates that there is no repetition of 3 Schwabe cycles in this record. In auroral occurrence, which is also an indicator of poloidal open field variations, we have a spectral peak estimated in this book, the Fivefold Sun, at about 32 years, but you see a large variation band of 4 years. In the sunspot record itself is found a peak at about 30.0 or 29.9 years, so it is also apparent in the toroidal field of sunspots. But the main source of evidence is in the geomagnetic records, which again are indicators of the sun's open field, where there is a peak at probably 30.4 years with an error bar of 2 years. We have many authors who explicitly found this approximate length. Here, however, we investigate more specifically in the AA geomagnetic index its antiphase component, i.e. the AA index net of the toroidal variations that are embedded in it, and also the variations in the dipole strength. In radionuclide records, we have also this rough estimate of about 28 years. All in all, we find 30.1 years as a realistic central value. You see, we do a sum of the reports for the sunspot number record separately for auroral occurrence, for geomagnetic indices, and for radionuclide records. We find a mean and a median for each. And if we look at the mean of the means, we have 30.15 years. If we look at the median of the medians, we have 30.05 years. This is the statistical basis from which is suggested 30.10 years as a central value for the length of this 3-cycle. Now we also have in this case the robust basis of observed estimated epochs for the extrema in this cycle. This is where we base the estimates on the antiphase AA component, the peak epochs of the antiphase component in the AA index. We have this direct assessment by Legrand and Simon, also direct assessment by Wilson and Hathaway, and an indirect control through the so-called Sargent recurrence index by Lockwood and his collaborators. We find indeed a series of 3 cycles with the first and second short cycle of about the same length, and the third long cycle. We find for these sets of 3 intervals of 31 years, 32 years, 31 years, and 29 years, which average out approximately at our central value. And you see the base epochs, the peak epochs, they are 2003, 1974, plus or minus 1 year, 1943, etc. This is how far back we can go in the AA record. Now we can do also a differential diagnosis of this length compared to other suggested close-by lengths. It is clearly not a 3-Schwabe cycle. It is also not the orbital period of Saturn, 29.4 years, which is different. However, this hypothesis is mentioned here because few authors, especially Scafetta, propose that there is a cycle of about 60 years, which would be double the Saturn period. Here it is proposed that in fact if the 2 periods, Saturn's orbit and this poloidal cycle, if they are indeed connected, this is because it is the planetary orbit which is an early consequence of a solar kinematic. and it is not the present-day source of the solar kinematic. Same reasoning for the 173-year cycle or 168-year cycle, which was in the previous period doubling sequence in the previous video, compared to the José planetary cycle. This period is composed, as was already stated, as the sum of 121, then again 121, and then finally 169 rigid rotations when it is idealized, i.e. 9.0 years twice and 12.4 years as a final third long cycle. The average of the sum, 30.1 or 30.3 years idealized, is also the second mode of the length of the Schwabe cycle, as we saw earlier. And if we now compare to the length of the Sun's rigid rotation, we have 411 plus or minus 3 rigid rotations for this length. 30.1 is 408 rotations. But the idealized number, 411, is a solar sequence number. You see, it is the 12th number of this sequence, which was introduced in the videos 1 to 6. We found this number in the differential rotation of the Sun, and it includes the very important number 60 for the kinematic of the differential rotation of the Sun. Is the presence of this set of 3 unequal cycles a way for the Sun to prevent the presence of a period 3 iteration in this sphere as a dynamical system? In recursive dynamical systems, especially in the logistic map case, there is a theorem by the mathematician Sarkovsky in the Ukraine in the 1960s that the return, the 3-period return in such a system is forbidden unless the system will undergo, on the longer term, chaotic bouts of behavior. So we see that in the case of the Sun, there is no such thing as a return of 3 cycles at a periodicity of 3 Schwabe cycles. We have something else instead. Maybe we can propose this conjecture that in the Sun as a dynamical system, if it nevertheless, for some reason, has to undergo a period 3 iteration, and it doesn't through a repeat of the Schwabe cycle, the superposition of a 3 cycle of 3 unequal periods in another dimension of this sphere, in this case an axial dimension, a poloidal dimension, would allow the Sun as a dynamical system to somehow go around the forbidden period 3 behavior. Then we have approximate double of the base period. We find a spectral peak about 57, 58 years, plus or minus 3 years, might be 61 years. Yoshimura already suggested a 55-year major long-term cycle in solar behavior, as opposed to the then proposed 80-year Gleisberg cycle. And again, Scafetta in this century proposes a 60-year solar cycle of planetary origin. In the data supporting the presence of this spectral peak, we have one peak near 60 years. It is here in the auroral data, but we have also a trough at 60.5 years. This is why, because of this conflict, the value of 57.5 is retained here as a spectral central value, You see here in a bin including 22 reported such detected periodicities. The phenomenology of the twice 30-year period is only here a speculative interpretation. We have nothing in terms of hard evidence to support any phenomenology. It can be interpreted to be introduced in the video 25 as a half-phase shift in the relation between the length relation between the poloidal cycle to discuss today and the toroidal cycle introduced in the previous video. It is also possibly because of this correspondence with a half-phase shift or for some other causality, it might be the approximate characteristic length of a deep solar minimum. In video 22, we already shown this rationale that during the Maunder minimum, we can have the addition over the length of a typical H-Faber pulsation, 88 years, of a poloidal base period in the first 30 years. And then in the next 57 or 60 years would have ensued the Maunder minimum deep episode of solar depressed activity. For the 118-year periodicity, we call it a suspected periodicity. There are only 6 reports of such a peak. What is interesting is that there is also in the spectra a detected period at 132 years, which we assign here to another sequence of oscillations, which will be discussed in the next video. And we see from the presence of these 2 nearby suspected or detected oscillations something which might explain that many investigators propose to detect a long variation band beyond the 80-year Gleisberg cycle up to 120 or 130 years. But in fact, here we suggest that it is composed of several distinct sharp oscillations, one of them here, the other at 132. The speculative interpretation of the phenomenology under this about 120 years cycle is a full phase shift in the relation between this suggested poloidal sequence and the suggested toroidal sequence. Then we have a period for which there is a very large band of uncertainty in its true length, 227 or maybe 253 or maybe 268. We have in all, you see, a very large number of reports that there is a period in this band. It was first proposed, as far as I know, by Sennett and Finney at the University of Arizona in 1990 from their radiocarbon data at 229 years, and it is certainly not a twinned peak or part of a smeared peak being centered at the 208-year period, the Sus de Vries period. They are actually, from a spectral point of view, quite distinct and separate, because for the 208-year period we have only 1 or 2 year error bar. The phenomenology of this periodicity we see in the final video on solar long-term oscillations as a synthesis. It can be idealized at a 242-year period. It is twice a full phase shift between the poloidal and toroidal sequences, which means that it is based on a second antiphase epoch, which is the minimum epoch preceding an odd-numbered sunspot cycle. For example, you see in this table 1701 is such a minimum epoch. It is found by subtracting 11 years from 1711 or 12 AD, which is a known minimum epoch. It roughly coincides with the epochs of observed super maxima in the aurora borealis. Here is shown in this table epochs of super maximum occurrence of the aurora borealis in the last 1,000 years from the catalogue of Fritz, 1872, the well-known canonical millennial catalogue of the aurora borealis. Fritz himself suggested a similar periodicity, but on slightly different grounds. And you see that the so-defined antiphase epoch coincides approximately with the epoch found in the observations by Fritz around this epoch, and finally 1822-25, which is well known from Dalton's work as the date of the so-called return of the aurora after its suppression from 1800 to 1820. Then we have this periodicity. It is about 16 times the base period and almost exactly 44 Schwabe cycles. We have 13 reports which indicate such a spectral peak. We have a large error bar again. It can be idealized at 485 years, which is then very close to our observed central value. Its phenomenology is unknown. And finally, and most interesting, is the 969-year period with only plus or minus 6-year error bar in the data as a spectral peak, and certainly below 1,000 years because, again, we have this trough at 1,050 years, which is detected in 4 reports. Paul Damon found this periodicity in 1976 as reported by John Eddy in the same year. Paul Damon found this significant power in the radiocarbon data. Now it is suggested that a 1,000-year periodicity in solar variations will be called the Eddy cycle, but the 970-year cycle is a Paul Damon cycle. And it is interestingly idealized here at exactly the same value, which is almost exactly 32 times the base period if it is idealized as 30.3 years. The phenomenology of this periodicity, again, here is purely speculated. It is 88 times 11 years, the Schwabe cycle, or it is 11 times 88 years, the H. Schwabe cycle pulsation. So there is a synchronization of these two periodicities over this length. Antiphase about 1701 of this era, and in phase about 1883 of the current era. This is very speculative and preliminary. Now we can ask whether these periodicities all are representative of poloidal solar oscillations or not. The base period indeed is, as opposed to the entire previous sequence based on sunspot numbers, the period doubling sequence with base period, the Hale cycle, which is a toroidal set of oscillations. For the 5 other periodicities introduced today, found in the spectra of solar variation or their proxies, they can be idealized as integral multiples of the poloidal base period, but we do not know, we have no direct evidence that these 5 periods are based as well on poloidal variations. The exception is perhaps the 242-year periodicity as the idealized length of the spectral peak found between 227 years and 268 years, because it seems to be reflected in the epochs of supermaxima of the aurora borealis, which is also a manifestation of the sun's open field. But overall, that this entire set, this entire sequence reflects poloidal oscillations remains a speculative assertion. This is the end of video 23. In the next video, we will introduce the sequence of so-called irrational oscillations. I thank you very much for your attention.